Hello everyone, welcome to online class of electrical machines 1 subject. In the previous classes, I have said about squad connection, 3-phase to 6-phase conversion. Today's class I will be telling about tap changing transformers. So they are of two types, no load and on load tap changing transformers, 3 winding transformers. So with this class, I will finish the syllabus of electrical machines 1 subject. All 5 units will be covered. Okay. So students, all of you should go through the videos of previous lectures. So each topic will be given in the description. So you can see the topic and accordingly you can find the videos. Notes also I have provided in the WhatsApp group. Go through all the notes. If you have any doubts, you can ask me. And prepare well for the exam and go through all the previous year's papers also. So fifth unit is all about transformers. So transformer is a static device which transfers electrical energy from one circuit to another circuit without changing the frequency. So we are transferring not only voltage, we are transferring the power, we can say, from one circuit to another circuit. So what is the need of this? To increase or decrease the value of voltages, we are using a transformer basically. So transformers are used for transmitting the voltages at higher values. The voltages that should be transmitted as it is economical. So there are four main parts in a power system: generation, transmission, distribution. Fourth one is utilization. So when voltage is getting generated some 11 kV like that or 633 kV, then it has to increase to 66 kV. So to increase from 33 to 66 or 11 to 66, or can be increased voltage, whatever. So voltage has to be increased. So for that purpose, step up transformer will be used. So again for distribution side, if you see, it has to be distributed to the consumers, that is to factories or industries or any commercial purpose, or to households. So we cannot distribute this much amount of voltage, that is 11 kV, 66 kV, 132 kV. We cannot distribute this much voltage. That is why again it has to step down. So voltage has to be stepped down and then it will be given for the distribution purpose to the substations and all. So step down transformer will be used. Again voltage has to be stepped down. So to increase and decrease the value of voltage, we are using a transformer. We have seen its construction, operating principle, okay, EMF equation, equivalent circuit, losses, efficiency, phasor diagrams, various tests conducted on transformer without actually loading the transformer. We are finding out its efficiency. We are testing the transformers through various tests. Okay, we are conducting tests on transformer to find out how much efficient the transformer is. So one point we have concluded in electrical machines, one subject, that regarding losses I am telling you. We have seen DC generators, DC motors, transformers. These three machines we have seen in detail, and we have seen in first unit we have seen about the various laws, and that is Ampere's law, Biot-Savart's law, Faraday's law, Lenz's law, and basics of magnetic circuits we have seen in the first unit. Second unit was common for both generator and motor, construction wise or various other things, okay, in second unit. And third unit, simple DC generators, everything, types, losses, working, characteristics. Then fourth unit was DC motors, same types, working, characteristics, speed control, 3-point starter we have seen, okay. Fifth unit, entire thing, transformers, single phase transformer, 3-phase transformer, auto transformer, 3 winding transformers, everything about transformers in fifth unit, okay. So all DC generator, DC motor and transformers, in the out of these three machines, what we can say, losses are less in transformer because there are no rotating parts in transformers. Whereas in DC generator and DC motor, rotating part will be there. Stator and rotor, two parts are there for construction wise if we see. So whereas in transformer it is a static piece of apparatus we are telling. There are no rotating parts in transformer. So there are no mechanical losses or rotating losses in the transformer. There are only iron and copper losses. So because losses are less, efficiency will be more in case of a transformer. Even if you do the experiments, if you have seen in the laboratory, we have seen in OCSC test also we have seen that efficiency of transformer will be more. Okay, it will be above 90, above 95 also. Okay, whereas other machines efficiency will be below 90. So this is the major difference between transformers and other machines. The transformer will be having high efficiency because there are less losses in transformer. Less losses are nothing but here there are no mechanical losses in the transformer, so efficiency will be high. Okay, so let us start today's class. Today's class I will be telling about tap changing transformers. So tap changing transformers are of two types: off-load tap changing transformers and on-load tap changing transformers. In detail we are going to see about the circuit diagram and working of these transformers. Then we are going to see about three winding transformers. Tap changing transformers. So the change of voltage is affected by changing the number of turns of the transformers provided with taps. Okay, tappings will be provided on the transformers. Yes, so that we can get the required value, whatever value we want according to that tapping, we can put the transformer. Okay, so change of voltage is affected by changing the number of turns of the transformer provided with taps. For sufficiently close control of voltage, taps are usually provided on the high voltage windings of the transformer. There are two types of tap changing transformers: off-load tap changing transformer and on-load tap changing transformer. So tappings are provided on the transformer for sufficiently close control of voltage. Okay, change of voltage will be affected by changing the number of turns of the transformer provided with taps. So like how we have seen in auto transformer also, there will be tappings provided, and according to the tapping, we can change the value of AC voltage. Okay, here I am talking about AC voltage. Transformer will work only on AC, it does not work on DC. So various tappings will be provided so that we can give the required value of voltage to the device which is getting connected to the transformer. So these transformers are tap changing transformers. So in that we are having two types: off load tap changing transformer and on load tap changing transformer. Let us see the first one, off-load tap changing transformer. So this is a diagram of an off-load tap changing transformer. These are the tappings which are provided on the transformer. So accordingly this arrow will be there. Na? It will be moving from this point to this point, whatever point we want. Okay. That is tap changing transformer. Off-load means what? There is no load here applied. So in this method, transformer will be disconnected from the main supply when the tap setting is to be changed. So this is very important, students, that transformer should not be connected to the supply whenever we are changing the tapping. We cannot switch on and change the tapping. We have to switch off the supply and change the tap setting. Tap setting is usually done manually. So manually only we are going to set the tappings. Tap setting. So off-load tap changing transformer is shown in the figure. So we are not connecting any load in off-load tap changing transformer. Whereas in on-load tap changing transformer, load can be connected. In order that the supply may not be interrupted, on-load tap changing transformer will be used. Okay. So whereas what we are doing in off-load tap changing transformer, we are switching off the supply, then changing the tap settings. But in case of on-load tap changing transformers, continuous supply will be given without any interruption. So such a transformer is called as tap changing under load transformer. So this is the diagram of an on-load tap changing transformer using a reactor. Various tappings will be provided. LV is the low voltage, HV is the high voltage. This is the reactor. Diverter switch will be provided here. So while typing, two essential conditions are to be fulfilled. The load circuit should not be broken to avoid arcing and prevent the damage of contacts. Second is, no parts of the winding should be short circuited while adjusting the tap. So these are the two essential conditions which have to be fulfilled. First one is, load circuit should not be broken to avoid arcing and prevent the damage of contacts. Second is, no parts of the winding should be short circuited while adjusting the tap. This is the on-load tap changing transformer diagram which I have already shown you. Now we are going to see its working. Tap changing employing a center tapped reactor as shown in the figure. Here this is a center tapped reactor. So S is here a diverter switch and 1, 2, 3 are the selector switches. Okay, S is the diverter switch here. 1, 2, 3 are the selector switches. Transformer is in operation with switches 1 and S closed. Switch 1 and S when it is closed, transformer is in operation. Now, when to change the position to tap 2, switch S is open and 2 is closed. S will be open and 2 is closed. Then switch 1 will be open and switch S to complete the tap change. It is to be noted that diverter switch will operate on load and no current flows in the selector switches during tap changing. So we have to note down that here whenever diverter switch operates on load, no current will flow in the selector switches during tap changing. And during the tap change, only half of the reactance which limits the current will be connected in the circuit. So this was about off-load and on-load tap changing transformers. So off-load tap changing transformers, what we have seen? So in this method, transformer will be disconnected from the main supply whenever tap setting has to be changed, and tap setting is usually done manually, and we cannot connect any load using this tap changing transformers. Okay, that means what? We have to we cannot connect the load means what? We can connect the load, but we cannot do it by switching on the supply. Supply should be switched off. So we can change the setting manually. Load will be connected, of course. That is another thing. But what I am telling here is that supply will be cut off. Then we can change the settings. Then again switch on the supply. Okay. So what is happening because of this offload tap changing transformer? Disturbance will be created. Continuous supply is not given to the load. Okay, or to the consumers. So that is the major disadvantage of offload tap changing transformer. Whereas if you see the construction wise, it is very simple as compared to on-load tap changing transformer. Okay. So in off-load tap changing transformer will be disconnected from the main supply when the tap setting is to be changed. Tap setting is usually done manually. Off-load tap changing transformer is shown in the figure. So when we see the on-load tap changing transformer, in order that the supply is not interrupted, and on-load tap changing transformer is used. Such a transformer is known as tap changing under load transformer. So two essential conditions are to be fulfilled while tapping. First one is load circuit should not be broken to avoid arcing and prevent the damage of contacts. Second is no parts of the winding should be short circuited while adjusting the tap. So this figure is showing a on-load tap changing transformer using a reactor R, and here S is the diverter switch and reactor is center tapped here. S is the diverter switch, 1, 2, 3 are the selector switches. The transformer is in operation with switches 1 and S is closed. Then to change the setting from tap 1 to tap 2, switch S is open and 2 is closed. Then switch 1 is then open and switch S is closed to complete the tap changing. So in this way we can do the tap changing. So here diverter switch operates on load and no current will flow in the selector switches during tap changing. And only half of the reactance which limits the current will be connected in the circuit. Now let us see 3-winding transformer. Let us see the definition of 3-winding transformer. Sometimes in high rating transformer, third winding is constructed in addition to the primary and secondary windings. Third winding is called as tertiary winding, and because of the 3 windings, transformer is called as 3-winding transformer. So in place of using only primary and secondary winding, a third winding called as tertiary winding is used. At that time, the transformer is called as 3-winding transformer. That is, sometimes in high rating transformer, third winding is constructed in addition to the primary and secondary windings. Third winding is called as tertiary winding, and because of the 3 windings, transformer is called the 3-winding transformer. Voltage ratings of all the 3 windings of the transformer are usually unequal. Primary winding has the highest voltage rating, tertiary has the lowest voltage rating, and secondary has the intermediate voltage rating. Okay. So now as earlier we have seen only 2 winding transformer Or auto transformer we have seen only with one winding. Okay, two winding transformer is a normal transformer. Then auto transformer is only one winding. So now three winding transformer is also there. Okay, so primary winding will have the highest voltage rating here. Secondary will have the intermediate voltage rating. Tertiary will have the lowest voltage rating. This is a three winding transformer shown in the figure. Okay, three windings will be wound. V1, V2, V3 are the three voltages here. This is V1, V1, V2, V3, I1, I2, I3. And this is the dot convention rule. According to that, direction of current can be known. Okay. So chief advantage of the three winding transformer is an economy of construction and their great efficiency. Okay. So it is economical to use a three winding transformer and it will give a very good efficiency. So schematic diagram of a three phase transformer is shown in the figure. For an ideal transformer, V2 by V1 is T2 by T1. T1 and T2, T1, T2, T3 are the turns here. So number of turns can be denoted by either N1, N2, N3 or T1, T2, T3. In some textbooks it is N1, N2, N3. In some textbooks it is T1, T2, T3. So we can take anything. So now for an ideal transformer, V2 by V1 is equal to T2 by T1 or V3 by V1 is equal to T3 by T1 because this is a three winding transformer. Now I1 T1 equal to I2 T2 equal to I3 T3. Most significant advantage of the third winding is that the harmonic generated by the primary and secondary winding extinguished by the third winding and third winding will be connected in delta. Voltage of the tertiary winding differs than the primary and secondary winding. So it is used for supplying the power to the auxiliary appliances like fan, tube light, etc. of the substation. So voltage of the tertiary winding will be different from the voltage of the primary and secondary winding and it will be used as giving the power supply to the auxiliary appliances like fans, tube lights of substations. Tertiary winding is used for the following applications. Reactive power will be supplied to the substations with the help of tertiary winding. Okay. Reactive power will be supplied to the substations with the help of this winding only. Then second one is the tertiary winding reduces the impedance of the circuit so that the fault current easily passes to the ground. Then third one is it is used for testing the high rating transformer. This is the equivalent circuit of a three winding transformer. So equivalent circuit of three windings transformer is shown here. R1, R2, R3 are the resistances. X1, X2, X3 are the impedances. V1, V2, V3 are the voltages. I1, I2, I3 are the current flowing through the windings. No load phasor, no load equivalent circuit diagram is also shown here. R0, X0. Okay. Now let us see the determination of parameters of three winding transformers. Parameters of the equivalent circuit can be determined from the open circuit and three short circuit test. So we are going to conduct open circuit and short circuit test here. So let us first see the short circuit test. Consider three impedances of the three winding transformer, that is Z1, Z2, Z3, and these impedances Z1, Z2, Z3 are considered as the base for performing the short circuit test. For the short circuit test, two winding will be short circuit and the third winding will be open circuited. Okay. Two windings will be short circuited, one winding is open circuited. In the first step, consider winding 1 and 2 are short circuited. So let us consider out of three windings 1, 2, 3, 1 and 2 are short circuited, third is open circuited. Low voltage winding is applied to the winding 1 due to which full load current flows through winding 2. So Z12 indicates the impedance of winding 1 and 2 and it is measured as Z12 is V1 by I1. Equivalent resistance is given as R12 equal to P1 by I1 square. Leakage reactance is given as X12 equal to root of Z12 square minus R12 square because Z is equal to R square plus X square. So X square can be written as Z square minus R square or X equal to root of Z square minus R square. Z12 is the series combination of Z1 and Z2 respectively. So Z12 can be written as R12 plus JX12 or Z1 plus Z2. So this is the diagram, connection diagram of short circuit test on three winding transformer. Variac will be connected here so that we can give variable AC voltages. Voltmeter is connected in parallel, ammeter is connected in series and in series with ammeter, wattmeter is connected and this is a three winding transformer. So first step is over. First step what we have seen, winding 1 and 2 are short circuited, third is open circuited. We have found various parameters. Okay. In the second step, third winding is short circuited with the second winding and the first winding is open. Okay. 2 and 3 are short circuited, first is open. Now on the second step. Low voltage source is applied across the third winding so that the full load current flows through the second winding. Z23 is representing the impedance of 2 and 3 winding respectively, and the below equation expresses it. Z23 equal to Z2 plus Z3. In the third step, second winding is open, first and third are short circuited. Okay, so what we are doing? 1, 2, 2, 3, 1, 3. Three steps we are short circuiting these three windings. Then now low voltage is applied to the third winding and full load current flows through the first windings. Z13 is the impedance of the first and third winding. Solving these three equations, we will get the leakage impedances Z1, Z2 and Z3. So Z1 equal to 1 by 2 Z1 plus 2 Z12 plus Z13 minus Z23. Z1 equal to 1 by 2 into Z23 plus Z12 minus Z13, and equal to 1 by 2. It is the Z1, Z2, Z3. So Z2 equal to this much. Z3 is 1 by 2 Z13 plus Z23 plus Z23 minus Z12. So now let us see the open circuit test. Open circuit test is carried out to determine the core losses, magnetizing impedance and turns ratios. In open circuit test, voltmeter, ammeter and wattmeter are connected in low voltage winding. Secondary side is kept open and the voltmeter is connected. Since the high voltage side is opened, current drawn by the primary is no load current and I0 measured by the ammeter A. Magnetizing impedance can be found by exciting current winding 1 with both winding 2 and 3 open circuited. Then we can have equation as A12 is V1 by V3, A13 is V1 by V3, A23 is V2 by V3, or it is equal to A23 by A12. So voltage regulation of a three winding transformer can be defined as the ratio of magnitude of the actual kVA loading of the winding to the base kVA used in determining the network parameters. Thank you everyone for watching the video. So I hope uh, today's class is clear to everyone. So we have done with the syllabus of electrical machines for subject. Today's class we have seen the tap changing transformers, on-load, off-load tap changing transformers, three winding transformers we have seen. So previous also we have seen all about transformers, all about DC generator, DC motors. Everything I have covered in all the previous topics. Search in my YouTube channel playlist. In that playlist, EM1 subject will be there. Other subjects also I am taking. So you select only this playlist, EM1 subject playlist. So in that, this is lecture 37. So 37 lectures I have given on EM1 subject. So topic wise I have given the lectures. Go through them before you write the main exam, final exam. Notes also I have provided in WhatsApp group. If you have any doubts, you can ask me. Okay. Thank you everyone for watching the video. I hope electrical machines one subject is clear to everyone. So this is the basic subject of electrical engineering students. If you are perfect with the basics, then you can go a long way. Okay. Thank you everyone for watching the video, and watch the videos from start till the end. Give the attendance in comment section. All the students subscribe the YouTube channels of all the faculty members who are taking you subjects online classes. If you any doubts in machine one subject, you can ask me. We are having lab also on this subject. Thank you everyone for watching the video.